Hey everyone, welcome to my channel. In this video, we'll be talking about the James Webb Telescope. It is currently active, doing observations out in space. Please remember to like and subscribe. Now let's get right into it. Fact 1. Infrared Telescope. Contrary to other previously deployed space telescopes, the James Webb Telescope is an infrared telescope. By using infrared, the wavelengths could be seen with the first stars and galaxies forming after the Big Bang. Infrared vision also allows the James Webb Telescope to study stars and planetary systems forming inside thick clouds of gas and dust that are opaque to visible light. This is very important because most other space telescopes are not infrared and therefore would not be able to see the things that the James Webb Telescope can observe. As you can see, the primary goal for the Webb is to study galaxy, stars, and planet formations in the universe. And in order to do that, you have to look back into deep space, where visible light may not travel all the way to Earth or to the space area where the telescope is at. And so using the infrared wavelength, you can observe things that you were not previously able to. Great. Let's get into the next fact. Fact 2. Beryllium gold mirrors. One of the most distinct features of the James Webb Telescope is the gold-plated beryllium mirrors. This is a new innovation in space telescopes that has not been used previously in other space telescopes. One of the challenges that resulted the scientists to use beryllium is because of the weight. Beryllium is a very light metal that is very strong for its weight and good at holding its shape across a range of temperatures. It's also a good conductor of electricity and heat and is not magnetic. Because it is light and strong, it's also used in supersonic airplanes and space shuttles. This is important because the James Webb Telescope has a mirror that's way larger than the Hubble telescope. And if they used the same material, it would have been too heavy to launch into space. And so beryllium is a really great choice for the material. Now let's get into the next fact. Fact 3. Sun-Earth orbit. The James Webb Telescope not only orbits around the Sun, but it also does an orbit that is relative to Earth. This orbit is actually called the L2 orbit. It is very interesting because this allows a stable configurations where the three bodies, the Earth, the Sun, and the telescope, could orbit each other and stay in the same position relative to each other. This particular type of orbit was discovered by Joseph Louis Lagrange. Lagrange pointed out that the gravitational pull of two large masses precisely equals the centripetal force required for the small object to move with them. The small object in this case is obviously the Webb telescope. The telescope needs this special kind of orbit because of a simple fact that when it's facing the sun, it really cannot see anything. And so it needs to be in a certain position to capture the deep space images without the sun blinding its camera. At the same time, with the relative position to Earth in a stable configuration, it allows astronomers and observers to stay in communications with the telescope as they use it to observe the deep space. And so as you can see, this very special orbiting is really critical to the success of the James Webb Telescope, and it is magnificently achieved through the Lagrange L2 orbit. Alright, let's get into the next fact. Fact 4. Publicly available. Even though the James Webb Telescope is a joint venture between various government agencies from around different countries, the telescope actually reserves 80% of its time for publicly available observation requests. As an example, a university or a astrophysicist or a astronomy research facility can submit proposals to the James Webb Telescope organization so that they can observe areas of space that they want to. Can you imagine being granted your proposal to to point the James Webb Telescope at the particular quadrant of space that you're interested in. This is exactly what the James Webb Telescope was designed for. The remaining 20% is dedicated to the director's discretion and other types of observations. But again, the 80% of the time, the Webb Telescope will be pointing at places that various organizations have submitted proposals for. And so you can see, it's actually a very large space telescope that is publicly used. Alright, let's get into the next and final fact. 5 layers of sun shield. Now, because of the way the Webb Telescope is orbiting, especially with nothing blocking it, the heat from the sun is extremely powerful. Without the 5 layers of sun shield, the Webb Telescope will probably malfunction and its equipment damaged by the extreme heat of the sun. And so it is critically important for the Webb Telescope to have so many layers of sun shield so that it could dissipate the heat from the sun and continues its very fine instrumental measurements and observations of the deep space. Now you may ask, why is there 5 layers? Why not just 1? Well, each successive layer of the sun shield is cooler than the one below it, and the heat radiates out from between the layers, and the vacuum between the layers is a very good insulator. One big thick sun shield will conduct heat from the bottom to the top more than the 5 layers separated by vacuum. The sun shield is made of lightweight materials with special thermal properties called kapton, which also is specially coated. The sun shield also has a special shape so that it could radiate heat in all different directions. The 5 layers are needed to block and redirect heat to get the telescope down to the required temperature within the margin of error. As you can see, the sun shield is absolutely a very critical part to the functioning of the Webb Telescope. Well, that's it for my video today. Thank you so much for watching. Please remember to like and subscribe. See you next time.